Wait a minute. So is there any doubt from the previous class? We did the preparation of carboxylic acid from Grignard reagent, right? So we completed that, and now we have two more methods of preparation. And the first is from acyl chloride, acyl halides, or acyl chloride you can say, and anhydrides. They are functional group, acyl anhydrides. Now see how we are going to prepare. This is your RCOCl, is the acyl chloride. There are two methods to prepare carboxylic acids from here. And in the first one, you are going to do the hydrolysis and you will directly get RCOOH plus Cl minus. And in the second method, you are going to do the hydrolysis in the presence of base. In the presence of base, then you will get RCOO minus, carboxylic anion, plus Cl minus. After this, you are going to do the hydrolysis in the presence of H plus. Then H plus will go and connect with this carboxylic anion, and you will get carboxylic acid. So please do write it. Alia, how is your pre-board? So this is how we prepare carboxylic from acyl chloride. Please do let me know when you are done with this.
Yes,
Now for the anhydride, as you know that this is pure anhydride in which benzene group is there twice. So what will happen? This will be totally oxidized into C6H5 COOH, and it will be 2 mole of carboxylic acid. This, and this is your benzoic acid. So I'm going to expand it a little bit, and you will get it how this product formed. So it's very easy. There is the structure is like this. This is your benzene, and then it comes C double bond O, and then it comes like this, and this is basically folded twice. So in this way, this carboxylic acid will be formed of 2 moles. C double bond O, OH. If you want to see in the other way, you can see that if you have C6H5 COO COCH3, and if you are going to do the hydrolysis, this is same. You need to do the hydrolysis, that means reaction with water. You will be getting, I'm going to expand it a little bit more. So you can see this is your C6H5, and then C double bond O, and then O, and then C double bond O, and this is your CH. And if you are going to do the hydrolysis, I just expand this formula. Then what will happen? This will be broken, and this part will be carboxylic acid, as well as this part will be also converted into carboxylic acid. So you will get C6H5 C double bond COOH, and then again from this side CH3 COOH. So this is how we prepare carboxylic acid from anhydride. That's very easy. Earlier there is an extra class on Friday. The time will be sent on Thursday. What time will you be free, Nafisa and Alia, on Friday?
Anytime.
Anytime. Okay. Okay, thank you, Alia. Please do let me know when you are done with this.
Yes, certain.
Very good. Alia, what about you? Also, I think. Okay, very good. Just do a little bit hard work. Then you will get a good marks also. Sixth, preparation is from esters. From esters. So in this also, we need to do the hydrolysis in the presence of acid. So this is your ester. I'm going to make C double bond O and then C2H. So if you are going to do hydrolysis in the presence of acid, you will get alcohol as well as carboxylic acid. So this bond will be broken, and then you'll get C double bond OH along with this C2H5OH. Just write it as 3O positive. Hydrolysis in the presence of H plus. So this is what you will get. Okay. There is another method to prepare carboxylic acid in the presence of. There is another method to prepare carboxylic acid from ester. That is, if you have CH3, CH2, and COOC2H5, and if you are going to react this with alkali, that means NaOH, sodium hydroxide, then what will happen? This will be broken and Na will go with oxygen. Then it will be converted into a salt, CH3, CH2, and then again CH2, and then C double ONA, along with the formation of alcohol, C2H5OH. The right part will be converted into alcohol. And when you are going to do the hydrolysis in the presence of acid, that means H plus. So H plus will replace this Na, and it will be CH3, CH2, and then again CH2, and then again C double OH. Please do write it. Please do let me know when you are done.
Yes, certain.
Please do let me know when you're done with this. Very good. Ali, are you done with this? Now, so the preparation of carboxylic acid completed here. Now we are going to do the chemical reactions. So see, in chemical reaction, we are going to study about the reactions involving cleavage of OH. Reactions involving cleavage of OH bond. So in this, we need to study about the acidity of carboxylic acid. Acidity of carboxylic acid. So basically, this carboxylic acid is an acid. So we are going to study reaction with metals, and you have studied it in class 10. Reaction with metals and alkalis. Since carboxylic acid is acid, so when it will be reacting with metal, you will get a salt and evolution of hydrogen gas will take place. As you can see, if you have a carboxylic acid RCOOH and you are going to react this with sodium, then what will happen? This hydrogen will be replaced by this Na, and you will be getting a salt, carboxylic acid salt, and hydrogen will be released. So in order to balance it, we just need to multiply it by 2. Is that clear? And if you are going to react this with the alkalis, that means base, acid plus base will give you salt plus water. So RCOOH plus NaOH, sodium hydroxide, that will give you RCOONA plus H2O, water. Okay, so this is what you get. You can write positive here, negative here, positive here, negative. And if you are going to react this with NaHCO3, sodium hydrogen carbonate, then you will get carboxylic acid salt plus water plus evolution of CO2 will take place. So if you are going to react this with carboxylic acid plus NaHCO3 with sodium hydrogen carbonate, you will get RCOO minus Na plus and then H2O and then CO2. Please do write it. Please do let me know when you are done with this. That
Yes, written.
you are also done with this earlier. So it's very easy. Now see, I'm going to show you a resonating structure of this carboxylic acid, how it stabilizes itself with the help of resonance. If you are going to react this with H2, then what will form? This will give H plus and it will form H3O positive along with the formation of RC double bond O negative. Now I'm going to do the resonance of this. As you know, this will take carbon's electron and it will satisfy carbon's bond. So it will be RCO negative and then double bond. And we can write the hybrid resonance hybrid as this O and O. And double bond moves from here to here. So it will be written like this. This is resonance hybrid. Please do write it. Also, it's very important to note that acidic character is directly proportional to minus I electron withdrawing group minus R electron withdrawing group in resonance, directly proportional to the value of K acid dissociation constant, inversely proportional to the donating group and inductive effect, inversely proportional to the donating group plus R, and inversely proportional to the pKb, which is opposite pK, which is opposite of K. So whenever in a compound or in a carboxylic acid, if electron withdrawing group are more or more powerful, that will be more acidic than the other one. Please do write it first.
Yes, sir, finished.
Earlier, you are also done with this. See, I'm going to write it. It's very easy. This is your C, and this is your O, and this is also your O, which is the resonance hybrid. This is negative sign. And if there is electron withdrawing group, that means it will attract or take electron from carbon. In this, it will be more stable. So I'm going to write a point about this. So we can say electron withdrawing group, that is EWG, stabilizes the carboxylate anion, stabilizes the carboxylate anion and strengthens the acid. That means it will be more acidic. And if you are going to, have an electron donating group, that means it will donate electron to this. This will decrease acidic character. So if electron donating group is there, ED is electron donating group. GP that stand for group destabilizes. Destabilizes the carboxylate anion and weakens the acid. Since it is with negative charge, it becomes more rich in electron, so it doesn't require any electron. And if you are going to add any electron donating group, that it has already negative charge. That's why it destabilizes carboxylate. Please do write it. And then there is a series, which one is more acidic and which one is less acidic. Electron withdrawing power, electron withdrawing group. So CF3 has the most, then comes NO2, then comes CN, then comes F, then comes chlorine, then comes bromine, then comes iodine, and then comes pH. Please do write it. Let me know when you are done with this, please.
Yes, sir. Finish.
Now see, I'm going to give you a question on this. Which one is more acidic? This is your benzene in which OCH3 ethyl group is added. This is your benzoic acid without any group attached. And this is your NO2 that is connected with carboxylic. Which one is more acidic?
Sir, the last one. Nitro.
This will switch. This is your minus R effect that will, this is your electron withdrawing, and this OCH3 is electron donating. That's why its acidic character decreases. And if I'm going to tell it, say A, B, C. So C is the most acidic, then comes B, and then comes A, because due to this electron donating group, it decreases its acidity, and there is no donating or withdrawing. That's why it is in between. Is that clear?
Yes, sir.
Can I change the slide?
Yes, sir.
Very good. Now see, we have another type of chemical reaction, that is reactions involving cleavage of COH bond. See, first is formation of anhydride. Formation of anhydride. How we are going to form anhydride? It's very easy. CH3 C double bond O OH. We are going to take 2 moles of this carboxylic acid. Please write it. Very good. So basically, this is how you prepare anhydride. Ethanoic anhydride, it will be known as. Is that clear? Can I change the slide?
Yes, sir.
The next one is esterification. This chapter is almost completed. Next chapter we are going to do is amines in the next class. So see, esterification, you have studied this in class 10th also, that carboxylic acid react with alcohol in the presence of acid, in the presence of acid to form ester, and this is how ester will form. C, RCOO dash, and there will be removal of. So what happens here? Here, basically, this OH and this H will be removed, and this R will go with this. So in this way, you can easily prepare the ester. So please do write it. And the third is basically reaction with PCl3 or PCl5, PCl3, and associate and associate. So if you are going to react this RC double OH with PCl5, then you will get acyl chloride, that is RCOCl plus POCl3 along with HCl. If you are going to do the reaction of carboxylic acid with PCl3, then you will get 3 moles of RCOCl along with phosphorus acid H3PO. And if you are going to react this carboxylic acid with associate cyanide chloride, then you will get RCOCl plus SO2 plus HCl. Let me know when you are done with this.
Yes, sir, done.
Very good. So it's very easy. Now the next chemical reaction is reaction with ammonia. That is NH3. NH3 is a base, as you know that, and this is NH3 is base and carboxylic acid is acid. So if you are going to react this CH3 C double OH plus NH3, then what will happen? This will release H plus. This is a reversible reaction. This will release H plus. This will be like CH3 C double O minus plus H plus, and you can see NH3 has a lone pair, so it will attack on H plus and becomes NH4 positive, and this positive and negative will be together. So the product will be like CH3 C double O minus NH4 positive, electrostatic force of attraction. And then if you are going to do the hydrolysis, sorry, heat, then elimination of water will take place and it will form CH3CO NH2. Amide will form. Amide will form. H2O will be eliminated. Two hydrogen from here and one oxygen. And the rest part will be as it is, so amide will form. Please do write. Please do let me know when you are done. Done.
Yes, sir, done.
Okay. Now see, this reaction is very important because the compound is quite famous. And this is your carboxylic acid, and if you're going to react this with NH3, you will get ammonium benzoate, C double O minus NH4 positive, ammonium benzoate. And if you're going to do the heating, H2 will be removed, eliminated, and you will get CONH2. That is basically this is your benzamide. Please do that. And if you have two carboxylic acid group in benzene, like this one, C double OH and C double OH, and if you are going to react this with NH3, then both the carboxylic acid will be converted like this. It will be C double O minus NH4 positive. And again, it will be C double O minus NH4 positive. And if you are going to do heating, then there will be elimination of two H2O, one H2O from above and bottom, top and bottom, and then you will get this CuNH2 and CuNH2, CuNH2 and CuNH2, and this is known as phthalimide. Phthalimide. And if you are going to do a strong heating in this, strong heating. Wait a minute, please write up to this. We are going to do the strong heating on this. Strong heating, then minus NH3. NH3 will be eliminated. I will write the product. Please do write it up to this. Do let me know when you are done.
Yes,
Are
sir.
you done with this? Well, now say if you are going to do a strong heating, then you will get phthalimide. This was phthalimide, and then you will get a product like this, which is known as phthalimide. C double bond O, in the same way C double bond O, and then NH, and then this. This is known as phthalimide. Please do write.
Yes, sir. Done.
After this, basically your reaction involving COOH group, C double OH group. So the first is basically reduction, and as you can see, reduction. So if you are going to do a reduction using a very strong reducing agent in carboxylic acid like LiALH4, lithium aluminum hydride, B2H6, that is diborane. And after this, in the second step, you are going to do the hydrolysis in the presence of acid. Then this carboxylic acid will be directly converted into alcohol. Then directly converted into alcohol. As the way you can see with an example, CH3 double OH. And if you are going to use this reagent in the first step and second step, so there will be an alcohol formation like this. Please do write. So I'm going to give you some questions. You are going to solve it. In the next class, for the first, we can easily go for a means. Let me know when you are done with this.
Yes, it on.
Let it. Now I'm going to give you questions. Please do. And send it to me, Alia, you also. And this question is stand for 6 marks. So please write in words and also take example with the reaction for the reaction. Is that clear?
Yes, sir.
Are you done with the first question? Have you written it? Yes or no?
Yes, sir.
So this is the reaction you need to complete first tolerance reagent and then pH, MGBR, in the first step, and in the second step is free of cost. Okay, I'm waiting. Wait a minute. Uh, Let me know, Alia, when you are done with the first question so that I can slide it down. No, wait a minute. Please do it. We'll be back in a minute. Okay. Let me know when you are done with the question.
Yes, sir. Done.
Please do. And send it to me or WhatsApp. Nafisa and Alia, you're done with this.
No, sir. Still writing.
Okay. Alia, are you done with this?